Hi, I'm Twana from LlamaIndex, and in this video let's have a look at how you can use Qdrant in various ways with LlamaIndex. In this quick intro, we'll be looking at two very simple agents, one function agent and one workflow that we built from scratch. And there are various ways you can use Qdrant with LlamaIndex. You can either run Qdrant locally, you can use Qdrant Cloud, or you can also use LlamaCloud with Qdrant Cloud set as the sink. So I'll be showing you how to use Qdrant that runs locally, and at the end we'll also have a look at how we can use LlamaCloud as our index with Qdrant Cloud being the sink. Okay, so to start off you will have to install a few requirements and also set your environment variables. We will need your OpenAI API key if you want to use OpenAI. You don't have to. And we will also need your LlamaCloud API key if you want to join in the very last step. Once you have those done, what we'll be building at the end of the day is a very simple agent that can do one of two things. It can either query a database or it can write new statements to a database. So think of it as an agentic RAG alongside database management. Once you have Qdrant running locally, you can do that by following these instructions here. I have it running already. You can then connect to your client and create a connection. So I am setting up my clients here, both a client and an async client. And if you like, you can skip this step. The only thing it's doing is it's checking whether there is an existent collection called my collection and deleting it if there is, so that you can start afresh every time you're running this course. And then I am simply creating a vector store. One other thing you can do when using Qdrant is hybrid search. You can use both sparse embeddings and dense embeddings. And here I am setting my sparse embedding model. All right, once I have that, the next thing I can do is define some global settings. Here I am creating a node parser. So this is basically telling Qdrant that we want to create chunks of a various size and with various overlap. And you can think of nodes as these document chunks. So I create this setting, and then I'm also going to create some dummy documents. This is a very simple intro. So we're going to be going with very simple documents. We have one document that is a statement about LlamaIndex and another document which is a statement about Qdrant, and that is it. Now that we have these, we can write them to our vector store index. So we create an index from these documents. We also set the OpenAI embedding as our dense embedding model. This will be using the default embedding model, which is an ADA model. And we do that. So now we have a vector index, which has been vectorized with OpenAI, that has just two document nodes in it. So we can already start doing some things with this. We can do some RAG, and I can ask the question, what is Qdrant? And ideally, I should be getting a response based on the context I have in my vector index. Instead of this, we can also ask a question that it should not be able to answer. Who is Twana? And ideally, we should be getting a response that indicates that it doesn't know who Twana is. So this is a great example because in the next step, we want to be able to create an agent where if there is information missing, we can actually add it to the collection we have. So to start building an agent, the first thing I want to do is create a simple function agent. A function agent is basically an agent that can accept a list of tools, and these tools can also be Python functions. And in this case, I want two of these Python functions. One called writeStatement, which expects a statement and inserts that to our index. And the other called queryCollection, which is very similar to this RAG app you saw at the top, which simply queries our query engine with that query. So let's create these two functions. And the other thing I do here is that I provide some descriptions. These are quite important because the underlying LLM that we will use for our agent will use these descriptions when making decisions about which one to pick given the incoming user query. So here for the writeStatement, I describe it as useful for writing statements to a collection, and the other one I describe as useful for querying the collection. And then finally, I create my function agent. I provide my two functions as tools, and I also define a system prompt. And this system prompt is basically a way for us to explain to the LLM what its purpose is, what its role is. So I do that. And then before I query it, you can, if you want, skip this entirely, but I have created a helper function called view agent steps. It looks like this. And basically what it's doing is, as the agent is running, it is printing out each of the agent steps that are being taken. So a tool call, what the input to the tool call was, what the response from the tool was, etc. So let's define that. And then let's, for example, say save this Twana is Devrel at LlamaIndex. So we had seen before that it didn't know who I was. So let's do this instead. And we see that this time we called the function write statement, and the statement was Twana is Devrel at LlamaIndex. So now if I ask the question, who is Twana, I should get the response, Twana is Devrel at LlamaIndex. Perfect. Next, I want to show you how you could build your own custom workflow. This is a way to create agent workflows where you have full control of the behavior of the agent. I'm going to be creating an agent that uses the structured output functionality of models to, first of all, classify what the incoming query means, what the user is asking for. And I define that by creating a Pydantic model called actions. And actions could be either save to docs or ask. And ask is just a list of queries, and save to docs is a statement. So I define that, and then I can create a workflow. Workflows have two main components in LlamaIndex: events and steps. An event is emitted by a step, or it can be emitted from the outside world as well. And if a step is subscribed to an event, that means that step is going to run once it's emitted. And a step could also produce an event. So we have two special events, the start event and the stop event, but anything else we can basically define ourselves. So I've created two events, the write statement and query index event. Write statement just has a statement, and query index has a list of queries. Now, when I initialize my Qdrant document agent workflow, I also define a structured LLM that is meant to respond with this particular structure. I then also provide a slightly more detailed system prompt. And then the first thing we can do here is, once a start event is received, we can ask the LLM to return some actions for us. So here the LLM is ideally classifying the user's incoming query. And then we either emit the write statement event or the query index event based on what the actions in the evaluated actions were. The next two steps are query index and save to index. So query index will only run if there's a query index event, and save to index will only run if there is a write statement event. For now, what we're doing is simply printing out these statements to see if the right step was picked or not. And we'll also print out the actions that was generated by our structured LLM. So let's do that. Let's create our workflow. And this time let's go with a different query, and let's say who is Casper. And here, as you can see, we have the action ask with who is Casper. It got an ask event, so we then printed out this statement, request a query index with the following query. Perfect. Now we can actually fill these steps in with things that actually work. This next step is only filling these steps in, which is very similar to what you saw in the functions above. And now we will actually be writing to our index or responding based on the user query. Let's go with the question, let's remove this for now. Who is Casper again? Okay, so we did pick the correct action and there is no mention of Casper. So let's instead do this, save this. Casper is devrel at Qdrant. Okay, now we can maybe ask something different. We can maybe even ask two questions. Who is Casper and who is Tawana? Okay, so this time we have two queries, and that was forwarded to our query index step, and I got the response Casper is devrel at Qdrant and Tawana is devrel at LlamaIndex. The following things I want to show you is simply how you can make use of more real-world data with your Qdrant indexes. So these were dummy data. This was like simple one sentence statements. But if you want to be able to write real-world data into your Qdrant indexes, you can make use of a number of data loaders and readers that we have in LlamaIndex and as integrations that you can find on LlamaHub. This is a very simple example of a reader that is able to read web pages and write the contents to a given index. So for example, here we may ask to write the URL about LlamaIndex workflows. And for example, if we were to run the same exact workflow, we should be able to get an ask event, what are LlamaIndex workflows? And we get a response based on the content of this URL. And finally, let's have a look at how you might be able to use Qdrant Cloud. One way to use Qdrant Cloud is via LlamaCloud. So let's have a look at that. Here, as you can see, I have a index called LlamaIndex. What's special about this index is that not only is it using Qdrant as my vector database, but I've also set up Google Drive as a data source for it, and I have a Google Drive folder with one PDF in it, which is the same workflows documentation page. And this means you'll be able to use Llama Parser's advanced parsing techniques and vectorize and store the contents of it in your Qdrant vector store. So the way I can now use that is by providing the name of my collection, my project name, and then I can simply go ahead and use it the same way I used my initial local index and ask for an answer to the question, what are LlamaIndex workflows? And I get the same answer. And there we have it. So these are various ways you can use Qdrant with LlamaIndex, build your own custom agent workflows, or use simple function agent tools as well.